Okay, hi there. I wanted to give you guys a quick review of part of your Chapter 3 reading. This particular review is just going to focus on cognitive development and in particular the work of Jean Piaget. Many of you guys are familiar with Piaget's work already, maybe from previous education courses or from previous psychology courses. So hopefully this is a little bit of review. So I'll go through it rather quickly. And if you guys have questions, we can continue to discuss them. So one thing that came out from the readings is that while everyone can develop at different paces, we all tend to develop according to the same milestones and in consistent order. So we can look for certain milestones and universals when we think about children and the way they develop. For instance, children usually learn to sit up, usually learn to roll over before they can sit up. They learn to sit up and crawl before they can walk. So these are typical types of milestones that most children go through in their development. However, as we know, especially in those younger years, that children develop at different rates. Not everyone learns how to walk and talk at the same time, and there's a lot of leeway in those ranges, which is why we tell parents to try not to worry if their child's not talking and their friend's child is already speaking in sentences. Development occurs often in periods of rapid growth and spurts. So even though a child may hit a plateau at some point and seem like there's no change, learning is still occurring. And this is the thing about the cognitive development that's different from behavioral theories or behaviorism. Behaviorism really focuses on the idea that learning is a process where you see a change in behavior, whereas cognitive development says that learning can occur even if you don't see a change in behavior. And as a parent, I see this with my young son. He goes through plateaus where I really don't see any change in his behavior. His language skills stay roughly the same, maybe sometimes for 2 months. He's only about not quite 2 years old now. And so he might go through a period where I see very little change and he's still sort of saying the same little words and phrases and he hasn't really picked up a lot of new information. But he's still learning. And then there's going to be a day where he's going to have a spurt. All of a sudden, he's going to be speaking sentences and, using a lot more complex language. So this is what, is said about cognitive development. So the idea, though, is that we all go through predictable stages, and what affects these stages is a combination of both our genetics and our heritable developmental properties as well as the environment. So how we interact with things around us and people around us. So these affect our process of maturation, getting older, as well as our temperament, which is said to be something that is innate and we're born with, tends to play a role in how we interact with our environment. And then there's also a sensitive period, which is generally these younger formative years. The first years of life are very sensitive, and that's because the brain is such a sponge and it's absorbing massive amounts of information so quickly. But as we've learned from other readings on other theories, there's also an emotional sensitivity that's happening here where our interactions with adults plays a strong role in our ability to feel confident and well adjusted and well attached. So the sensitive period is especially critical, not just for cognitive development, but also for emotional security and emotional development. So very quickly, Jean Piaget, his work began in the 1920s through the 1950s. He was inspired a lot by originally just playing with his own daughter and seeing how she learned and how she thought. This evolved into a series of experiments where he would ask questions and give a little task to different age groups. And I've included some videos in the resources this module, and it gives examples of some of the kinds of experiments that Piaget did with kids. But he found through doing them with different age groups that they were thinking in different ways and able to process information more abstractly and maturely as they grew. So this really inspired sort of this development of this stage theory that he has. So he also said that children are very active learners, that they're experimenting with objects. So I like to compare this to thinking of children as a little scientist. For instance, I see my child playing make-believe with pots and pans and cups. He'll pretend to drink out of them. Or you give him a new object that he's never interacted with, and you'll see that he'll pick it up and start working with it and trying to figure out how it works. So this is an example of a child being an active learner and seeking to make sense of new information constantly. So how they make sense of new information is they use prior knowledge to help create the basis for that. So this is the sort of cornerstone behind this idea of constructivism. Constructivism, you can think about this in terms of just what the word stands for. You're constructing knowledge. So you think about building a house. You're putting up you dig the foundation, you put the framework up, and then you fill it in with all of the details. So same with knowledge. You have to start with foundation knowledge, and you have to sort of provide the scaffolds which help support the learner in obtaining new knowledge, and then they can start to put it in those details. So constructivism is this idea that we don't start with a blank slate. We start with prior information, and that helps us to learn something new. So, if you have prior information of using crayons to color, then it might be easy when you pick up a pen that you recognize that that is a writing utensil and you can write with it. So that's kind of the idea that you're learning something new, but you're using prior knowledge to help you learn. Also, Piaget talks about scheme theory, which is this idea that we have these mental mindsets or knowledge sets that help us understand the world. So, for example, we have a schema for what a dog would look like. So we might think, okay, dogs have 4 legs and they have hair. So our schema for dog would be creatures with 4 legs and hair. And as we get older, we recognize that, hey, other creatures can have 4 legs and hair. Horses can, cats can, other animals can. So we're adjusting our schemes constantly. But we have schemes not just for understanding objects and things, but also procedures. So think about the schema you have for going to a grocery store, right? If you think about the procedures that you have to go through when you go and shop for groceries, you go in the door, you get your cart, you probably go to the produce section first, then you work your way through the aisles, or maybe you don't go through the aisles, maybe you go around the outside, and then eventually you make your way to the checkout, and there's a process for that as well. So schema are not just ways of understanding objects and sort of declarative knowledge, it's also procedural knowledge. Okay, so with that being said, children learn, as well as adults learn, through 2 processes called assimilation and accommodation. Assimilation is this idea that we already have an existing schema and we can add something to that. So when I'm obtaining new information in math, I already have a schema for math. Maybe my math teacher teaches me a new technique. That's something I can assimilate into my new schema, into my existing schema. So assimilation is just this idea that we learn a new word or we learn a new concept, but we already have prior knowledge and prior information on the schema, so it goes into sort of that box with that information. Accommodation is when you realize you have to change your schema. So this might mean, or you might have to create a whole new one. So a good example of that is a misconception. A lot of kids, for instance, in science, you may have seen this video called A Private Universe, really good older video, but it's all about the misconceptions kids have about science and how the Earth rotates around the sun. So once you understand that true concept, you have to modify your schema, right? Because you realize that you had misconceptions about how it worked, and therefore you have to just change the way you believe in something. So that's very disruptive. And it's really important, though, when you're working with kids to recognize if they have misconceptions and help present them with new information and new knowledge to help them modify their schema if they have those misconceptions. And that can be really uncomfortable for kids and for adults. We don't like to change our minds on things. We're very resistant to that. So new information that can kind of create some discomfort and what we call cognitive dissonance is really helpful in modifying a schema and accommodation, because we're basically telling someone that they have to change the way they think. You see this a lot in social settings too, right? Like if you grew up around certain kinds of people or in a certain church or certain religion, and all of a sudden you're confronted with people who are very different from you, in terms of their beliefs, and you have prior misconceptions about those people, and then you had to realize, okay, I'm getting to know them. I realized maybe I was thinking about them and I was incorrect in my assumptions. That's another form of accommodation. So we do this not just as kids in school, but we do this throughout adulthood too. Okay, so the idea of having to have like that cognitive dissonance that makes us uncomfortable when we're accommodating is called disequilibrium. That's actually a good thing. Equilibrium is like basically I can explain things based on what I already know. So it fits well within what I already believe and know. That's being in equilibrium. It means everything's okay. We're in stasis here. Disequilibrium is when we feel uncomfortable because, hey, this doesn't exactly fit into my prior schema. I have a misconception about this, or I've never encountered this, so I don't know what to do with this new information. That is uncomfortable. But disequilibrium is actually like a good thing when we think of teaching, because we want to challenge children to think. We want to give them opportunities to expand their thinking and feel a little bit uncomfortable, because that's really the precipice of learning. Okay, very quickly, Piaget goes through stages of development, which you can read about on your own, but those younger stages is all about sensory development. And kids sort of having limited knowledge of object permanence. So if an object disappears from view, they cease to realize it exists. This develops, in that first year of life. You'll see that with an infant who all of a sudden you could put the object under a towel and they'll lift the towel. They'll realize the object still exists. So that's what object permanence is. But basically this is all about putting things in your mouth, tasting, touching, seeing, feeling, very sensory oriented stage. Pre-operationals from 2 till about first grade, and this is when language skills develop and you have symbolic thinking, so you can realize that you can represent something through a word. Kids can be a bit egocentric, so things can be all about me or mine, and kids aren't always great at multiple classifications, so they may say that's my mommy, but they may not say mommy is a doctor or mommy is a lawyer or mommy's a teacher. That's multiple classification. Now, I think that this can definitely occur as you get into those older 8 years in this stage. So I think we should look at these stages as being a little bit more fluid than just these years. Concrete is 6 to 7 till about 11, 12, so sort of that middle school age. Again, children are really showing a lot more adult-like logic, but we don't want to be fooled. That doesn't mean that they are adults. They still have a lot of inability to think really abstractly, especially like about social issues. That maturity, that emotional maturity is still not there, but they are able to start classifying things in multiple ways and use deductive reasoning and abstract thought, which is why, you think about math gets a lot harder as we start going into those grades, because it goes from being concrete to a little bit more abstract. Finally, formal operations is sort of that middle school age through adulthood, and this is again where you start seeing more proportional reasoning, being able to control multiple variables and separate variables and think very abstractly. You see a lot of the formal operational egocentrism in the adolescent years. So I would equate that to sort of this idealistic belief. And if you've ever heard a teenager say things like, oh, my parents just don't understand, or life's not fair, or why is the world this way? I mean, so there's a lot of idealism, which is beautiful, right? But it's a part of this sort of stage of still having a little bit of an egocentrism, but it's a different mechanism than it is when you're a baby. Okay, so what does all this mean as a teacher? It means we want to try to help kids have natural curiosity. We want to invite them to learn. We want to place objects around our room if we're working with young kids that invite them to learn and to invite them to experiment, right? Interact with the environment, ask questions. We don't just want to spoon feed all of the answers to our kids when we're teaching even older kids. We want to create problem-solving situations. We want to create critical thinking. So Piaget says, let's inspire kids to learn how to think. Give them rich and varied experiences. Help them construct knowledge. Don't just give them, don't just lecture all day or give them the information. And then make sure they've got some prior knowledge so that they can relate it to new material. And don't be afraid to encourage a little cognitive dissonance, push into some disequilibrium. It's important for teachers to sort of identify misconceptions, especially sometimes you don't even know kids have misconceptions, but when you do, that's a moment where they have to accommodate that knowledge. Hands-on is really important for thinking about learning in this way. We want to do project-based learning for our kids. This really is all the way up through high school. Project-based learning is a great way to learn. Provide opportunities to share opinions and perspectives. So we think about our discussions that we have, and we try to sort of employ the Socratic method. You can do this with your students. You can do this with kids as young as late elementary age. Provide informations that contradict beliefs. This is, again, the precipice of thinking. So don't be afraid to push students to think critically. Okay, so a question that I could come out, so these are some criticisms. And so I guess a question that I would have based on what I've read about Piaget and learned about Piaget is, do you feel like these stages are accurate for these age groups that were sort of assigned to them? That would be one question. And what are some ways you as teachers can capitalize on this cognitive theory in your classroom? So for your particular age group, your particular type of student, and your particular content area, what are some things you can do practically to capitalize on curiosity, encourage critical thinking, and encourage hands-on learning? So that's my question.